ToDictionary and ToLookup. These are the next two conversion methods that can be used in LINQ to convert IEnumerable or equeryable collections to other types, dictionary and lookup. Let's learn more about them in this video. But before start explaining these two methods, let's first do a recap for dictionary and lookup structures. I already explained both in other videos. Both are collections of key-value pairs. So, both consist of two parts, key and value. These could be of any data type, such as integer, string, boolean, object, etc. The differences between dictionary and lookup are the following. Key-value association. A dictionary is strict, one key, one value. Try to add a duplicate key, and you will get an exception. A lookup, in contrast, allows a single key to have multiple values. In other words, dictionary has each key only once, while lookup could have the same key more than once. Immutability. A dictionary is mutable, you can add or remove elements after its creation. A lookup, however, is immutable. Once it's created, you cannot change its elements. Null keys. A dictionary doesn't allow null keys, while a lookup can handle null keys. This is the difference between both structures. Let's now start with the first method, ToDictionary. It creates a dictionary of t key t value from an IEnumerable of t. So, it's to convert an IEnumerable collection into a dictionary. This method has 4 overloads. All 4 overloads will be used after the sequence we want to convert. So, we have the sequence, which is of type IEnumerable of t, then the method. Let's check the overloads one by one. The first overload accepts 2 parameters of type function. In other words, we have to add 2 lambda expressions for this method. The first lambda expression is to select the key, and the second is to select the value. The second overload accepts 3 parameters. The first 2 parameters are exact the same, such as the first overload, to select the key and the value. The third parameter is a comparer to compare the keys. For example, if we have keys of type string and we don't care about the case of the letters, we can use a string comparer to ignore case. The third overload accepts only 1 parameter. It's also of type function, so we use a lambda expression here. This is to select the key. The fourth overload accepts 2 parameters. The first one is the lambda expression to select the key. The second parameter is a comparer to compare the keys. It's like the second overload. These are the 4 overloads of ToDictionary method. It's important to know that the used lambda expressions here are selectors, not predicates. This means, we don't need to write a condition that returns either true or false. We only have to select the data we need. So, it's not a predicate, but a selector. You will see that later in the examples. Let's now look at some examples to understand each overload, how to use inside a LINQ query. I will start with the first overload. I have the following data table, which contains 2 columns, student ID and student name. Suppose I want to convert this table to dictionary, where the key is the student ID, and the value is the student name. Let's see how to do that using a simple query. First I added the data table with as enumerable. So, now I have an IEnumerable of data row collection. This is the sequence I want to convert to dictionary. After that I used a dictionary method. Here I use 2 lambda expressions. The first one is to select the key. As mentioned, the student ID should be the key, therefore I'm selecting it here. And the second lambda expression is to select the value, which is the student name column. In this way I converted the table to dictionary using the first overload of the method. The output is a dictionary of string. I mentioned at the beginning of this video that dictionary contains each key only once, unlike lookup which could have a key more than once. So, back to our example. Suppose the content of the table is now as following. As you can see, I have an ID more than once, which should be the key of the dictionary. So, what happens now if I am using this query? An argument exception will be thrown, because the key exists more than once. To handle duplicates when creating a dictionary from a collection that may have duplicate keys, there are various ways. Let's check a few ways to do that. The first one is by using ToLookup method instead of ToDictionary method. As you know, lookup could have the same key more than once. But in this case, we don't get a dictionary as output, but a lookup. So, in case a lookup suits our needs, we can use this option to avoid exceptions. The second way to avoid argument exception is to group by the key, and aggregate the values. For example, the following query. Here I used group by method, to group the rows of the table by the key, the column student ID. Now the rows are grouped by the key. Each group contains all rows, where the key is the same. For example, these two rows will be in one group, because the key is the same. After that I used a dictionary method with two lambda expressions. The first one is to select the key. Here I use the key of the group, which is the column student ID. The second one is to select the content of column student name. Here I am selecting all values inside the column for the current key. They will be converted to array of string. So, I have the key only once, and for the key I will get all values as an array. The output of this query will be a dictionary of string, array of string, and no exception will be thrown. This is the second way to avoid argument exception. Let's check the third way, where I will select distinct values. The query will be as following. Here I group the rows by the column student ID. I will get the same three groups. Each group contains the rows, where the ID is the same. Then I selected the first row from each group. If the group contains more than one row, I will get only the first row. This means, I have now an 𝗖𝗵𝗽𝗀𝐀 of data row again, which contains only these three rows. So, now we don't have any duplicate keys anymore. After that I selected the key and the value using two lambda expressions. In this way no exception will be thrown, and I will get a dictionary of string. These are three different strategies to avoid exceptions, in case the collection could contain duplicates. Let's now move on to the second overload. Suppose I have the following table, which contains two columns, the student name and the marks in English. I want to convert this table to a dictionary, where the key is the student name, and the value is the marks. I have these two queries. The first one is using the first overload of ToDictionary, and the second query is using the second overload. Let's see what happens in each query. The output of the first query will be the following dictionary. It's a dictionary of string, integer. As you can see, we have the name John twice, but it's written in different cases. Each name is considered to be a unique name, because the default behavior of the ToDictionary method is to be case sensitive. I used CINT function to select the value, because I want to get the value as integer, not as a string. Let's now check the output of the second query. Here I used current culture ignore case comparer. You have to know that the comparer will be performed on the keys only, not on the values. The query starts converting the rows into a dictionary. The first three rows are converted as follows. Now we are at the fourth row, where we have the name John again, but with a lowercase j. Because we are using the current culture ignore case comparer, this John is considered the same as the John already present in the dictionary. Here's where we face a conflict, because we have a duplicate key. So, an argument exception will be thrown. To avoid the exception we can again use one of the strategies I showed you before. In summary, if the ToDictionary method encounters this case, with the first overload, it would simply add another entry with the lowercase John as a separate key. With the second overload, it will throw an argument exception, because John with a lowercase j is considered the same as John with an uppercase j, due to the case-insensitive comparer. So, the second query will fail unless we handle this duplicate scenario. That's all about the second overload. Let's move on to the third overload. Here we only have one parameter to select the keys. As you know, dictionary must have keys and values. If we only select the keys, where to get the values? Let's see that using the following example. I have the following table, that I want to convert to dictionary. The column student ID should be the key of the dictionary. For that I will use the following query using the third overload of ToDictionary method. So, I am only selecting the keys from the column student ID using a lambda expression. The dictionary contains now the following keys. The values in this example will be the complete row of the student ID. For example, the value of the first key will be the first row of the table. The value of the second key will be the second row of the table. And so on, each key has the complete row as value. This means, the output is a dictionary of string, data row. So, if we don't select a value, the query selects the values depending on the data type we have. Here we have a data table, therefore the value will be the row. We can also achieve the same result using the first overload, for example this query. Here I selected the key and the value. The key is the content of the column student ID. The value is the complete row. The result will be exact the same such as the third overload, but using the third overload we don't need to select the value. It will be selected automatically. This example was about data table. Let's now use this overload for an integer array. I have this array and the following query using the third overload. What do you think? Which output should we get in this case? Arrays contain single values, just integers. The result of this query will be a dictionary of integer, where the key and the value are the same. So, each number from the array will be the key and the value in the same time, because arrays contain single values. This is how to use the third overload of ToDictionary method. Using this overload, an argument exception will be thrown, in case we have duplicate keys. To handle the exception, we again need to use a strategy from the strategies I showed you before. Let's move on to the fourth overload of the method, which has two parameters. The first one is to select the keys, and the second one is a comparer. So, here we again select only the keys, and we also use a comparer. It works the same such as the previous overload. Depending on the data type we have, the values will be selected automatically. And we have a comparer to compare the keys. These are the four overloads of ToDictionary method. Let's summarize the ToDictionary method. It's to convert an 𝗖𝗵𝗽𝗀𝗀 collection into a dictionary. It has four overloads. Using the first two overloads we select the key and value. The second two overloads are to select only the key. The values will be automatically selected depending on the data type we have. The second and the fourth overloads have a comparer to compare the keys. The first and third overloads don't contain comparer, therefore the default comparer is used to compare the keys. That's all about ToDictionary method. Let's now move on to the second method, ToLookup. This method creates a generic lookup of t key t value from an 𝗖𝗵𝗪𝗀 of t. So, it's to convert an 𝗖𝗵𝗪𝗀 collection into a lookup. It has also four overloads, which are exact the same such as the overloads of ToDictionary method. The first two overloads are to select the keys and the values. The second two overloads are to select only the keys. The second and the fourth overloads contain a comparer to compare the keys. The output of this method is of type 𝗖𝗵𝗪𝗀 of t key t value. Let's check some examples to understand how does this method work. I have the following data table that contains two columns and different rows. Suppose I want to convert this table to lookup, where the key is the column student ID, and the value is the column student name. I will use the first overload as following. The result will be the following 𝗖𝗵𝗪𝗀 of string. As you can see, we have the ID S1 twice, but it's written in different cases. So, each ID is considered to be a unique key. This means, if we want to read the value of the key S1 in uppercase, we will get only the name John as result. And if we use the key S1 in lowercase, we will get the name Max as result. Let's now use the second overload to do the same. Here is the query with a comparer to ignore case. The result of this query will be again the same. So, using this query no exception will be thrown, because a lookup could contain the same key more than once. In this table we have the same key in different cases, but because we are using ignore case comparer, they are considered to be the same key. Using ToDictionary method an argument exception will be thrown, but using ToLookup method no exception will be thrown. Using this overload, if we use the key S1 in uppercase, we will get the names John and Max as result. If we also use the key S1 in lowercase, we will get the names John and Max as result. So, both keys are considered to be the same key, because I used ignore case comparer. This is how to use the second overload. The third and fourth overloads work also in the same way. We only select the keys using a lambda expression, and the values will be automatically selected, depending on the data type we have. So, no need to explain them again. That's all about ToLookup method. Alright, we have had a thorough look at both the ToDictionary and ToLookup methods. As we have seen, ToDictionary is perfect for creating a one-to-one mapping from a collection to a dictionary, where each key is unique. On the other hand, ToLookup is excellent for grouping elements into a one-to-many relationship, allowing multiple values per key. Remember, the choice between these two depends on your specific needs. Use ToDictionary for distinct key value pairs, and ToLookup for handling groupings under a common key. These methods are powerful tools in LINQ, enabling efficient data manipulation and retrieval, making your code more readable and maintainable. The examples we have covered should give you a good starting point, but don't stop here. Experiment with these methods in your projects, and you will find them indispensable.